channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry for class 11th, and that has been the class is your 11th class. We had done your 10th class of class 11th here, where we had completed your unit. This is the part 1 we had discussed, and part 2 we are dealing for class 11th here. So in the same way we had started with first unit 8 unit which we had done in this, and that is still redox reaction. This is your unit 9. The name of the unit is hydrogen. So the unit 9 is your hydrogen, that what we'll have to continue here. So on hydrogen we had done lastly, which we had done, the last topic is your the preparation of dihydrogen, which is laboratory preparations of dihydrogen, commercial productions of dihydrogen. Then we'll discuss about the properties of dihydrogen, physical property, chemical property, reaction with halogen, reaction with dioxygen, reaction with dinitrogen, reaction with metals, reaction with metals ions and metals oxide, reaction with organic compounds. That till all lastly we had done. So you can just go for the videos that we had mentioned in the playlist as well in a sequence way. You can easily get it out. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In terms of hydrogen, we'll start discussing the question. First of this unit is your hydrogen. Question is, comment on the reaction of dihydrogen with chlorine, sodium and copper second sulfur oxide. So on the same way we have to talk about it. So we'll be going comment on the reaction of dihydrogen with the first we talk about for chlorine. So for chlorine here, dihydrogen reduces the chlorine into chloride, which is Cl minus ion, and itself that is get oxidized to H plus ion by chlorine to form a hydrogen chloride. An electron that pair is shared between hydrogen and chlorine, leading to the formation of covalent molecule. So we'll go for it. For dihydrogen, that is for chlorine, reaction of dihydrogen with chlorine. Here, dihydrogen reduces chlorine into chloride, which is Cl minus ion, and itself gets oxidized to H plus ions by chlorine to form hydrogen chloride. An electron pair is shared between hydrogen and chlorine, leading to the formation of a covalent molecule. So here, now we go for the another one, which is being for sodium. Second for the sodium. That we go for it. So for that, for sodium, Dihydrogen is reduced by sodium 2 from NaH, and an electron is transferred from Na to hydrogen, leading to the formation of ionic compound Na plus and H minus. So here for sodium it is dihydrogen. I just write it down for you to write it down so that it will be remembered to you. And dihydrogen is reduced by sodium to form NaH. An electron is transferred from NaH. Electron is transferred from Na to. So on the same way we go for it. That is being here. So Na2H here, leading to the formation of an ionic compound, which is Na plus H minus here. For the third one, which we'll talk about it, that is for copper second oxide. For copper second oxide, it will be dihydrogen reduces copper second oxide to copper in zero oxidation state, and itself gets oxidized to H2O, which is covalent molecule. So now we talk about for another one, which has been of course the another important one, that is your uses of dihydrogen. So we'll discuss about uses of dihydrogen. So in terms of uses of dihydrogen here, in this, the largest single use of dihydrogen is in synthesis of ammonia, which is used in the manufacture of nitric acid and nitrogenous fertilizers, where dihydrogen is used to manufacture of vanaspati fat by the hydrogenations of polyunsaturated vegetable oils like soya bean, cotton seeds, etc. It is used in the manufacture of bulk organic chemical particles methanol, which will be in the same way will be going to have, that is CO in the form of gas plus 2H2O in the form of gas in the presence of cobalt catalyst, which will give you CH3OH liquid. It is widely used for manufacture of metal hydrates as well, and it is used for preparations of hydrogen chloride, a highly useful chemical here, which is hydrogen chloride is HCl, that is in short we are calling those. In a metallurgical process, it is used to reduce the heavy metals oxide to metals, and whereas in the same way that atomic hydrogen and oxyhydrogen torches find us to cutting and welding purposes, where atomic hydrogen atoms that is produced by dissociations of dihydrogen with the help of an electric arc are allowed to recombine on the surface to be welded to generate the temperature of 4000 Kelvin. Even though it is used as a rocket fuel in space research, dihydrogen is used in fuel cells for generating the electrical energy. It has many advantages over the conventional fossil fuels and electric power. It does not produce any pollutions and releases a greater energy per unit mass of fuel in comparison to the gasoline and the other fuel. Now we talk about for hydrides here, and that has been the important one, so we'll go for it for the hydrides. So here we go for hydrides. In terms of hydrides here, this is an important topic as well. But this has not been asked in most of the question paper, but yes, you have to know about this, so that's the reason I had continued with the same. So here for the hydrides here, the dihydrogen under certain reaction condition that combines with almost all element except the noble gases to form a binary compound that called hydrides. If E is the symbol of an element, then hydrides can be expressed as EHX, which is MgH2, or that is EMHN, that is B2H6. The hydrides are classified into the three categories. So first we'll be going for the hydrides, what the hydrides are called, and then after that we'll talk about the your these types of the classified into here. So the hydrides are dihydrogen under certain reaction conditions that combines with all element except noble gas to form binary compound called hydrides. So if E here is a symbol of the element, then the hydride can be expressed in the form of EHX, where example we can say MgH2 or EMHN. So examples is B2H6. Okay, so the hydrides are classified into the three categories. The hydrides are classified into three categories. So the first category we have is, we will discuss one by one. The first category is ionic or saline or salt like hydrides. So either it has been ionic, saline or salt like hydrides. We'll discuss those. So for that, these are the stoichiometric compound of the dihydrogen that is formed with most of the S block elements, which are highly electropositive in character, and however the significant coefficient character is found in the lighter metal hydrides such as Li. For this it has been such as Li, H, BeH2, NgH2. In fact, BeH2 and MgH2 are the polymeric innate structure, and the ionic hydrides that been crystalline, non-volatile, and non-conducting in solid state. However, their melts conduct electricity, and electrolysis liberate dihydrogen gas at anode, which confirm the existence of H plus ion. On the same way, we'll be going to do 2H minus, which melt anode to give you H2 in the form of gas plus 2 electron. So this is the saline hydride. Now we'll discuss the saline hydride that react the violently with water and producing the dihydrogen gas. NaH solid plus H2O in the form of aqueous will give NaOH aqueous plus H2, that is in the form of gas here. So here that we have on the same way here that the lithium hydride is rather unreactive at moderate temperatures with O2 or Cl2. It is therefore used for the synthesis of other useful hydrides, and that is here lithium plus Al2Cl6 will give 2 LiAlH4 plus 6 LiCl, 2 LiH plus B2H6 will give 2 LiBH4. So now we discuss for the another that is hydride that is classified into the second category, which will be having is your covalent or molecular hydride. The second one we have covalent or molecular hydrides. The covalent or molecular hydrides here, where the dihydrogen that forms molecular compound with the most of the p block element. Most familiar were your CH4, NH3, H2O, and HF. For convenience, the hydrogen compound of non-metal that have also been considered as hydride for being covalent. They are volatile compound. And molecular hydrides are further classified according to the relative numbers of electron and bonds in their Lewis structures that were into that were according to the relative number of electron and bonds in their Lewis structures that will be into your I just write it down so that it will be clear to you. Molecular hydrides are further classified according to the relative number of electrons and bonds in their Lewis structure. are. So that will be, first we have electron deficient, the second is B1 electron precise, and the C1 electron rich hydrides. So in terms of these three, here an electron deficient hydrides, as the name suggests, has too few electrons for writing it conventional Lewis structure, which is diborane, is an example. In fact, the element of group 13 will form electron deficient compound. What do you expect from their behavior? They act as Lewis acids, and that is electron acceptor as well. So it is for the electron deficient, the example is Ba2H6 or group 13. Okay, now in terms of electron precise here, that compounds have the required numbers of electron to write their conventional Lewis structures. All electrons of group 14 form such compound, example CH4, which is a tetrahedral in geometry. So CH4 and group 14. Okay, for the another one, that is electron rich hydrides, 7 excess electron which are present at lone pair. Elements of group 15 and 17 form such compound. NH3 has 1 lone pair, H2O has 2 lone pair, and HF has 3 lone pair. What do you expect from the behavior of such compound? They will behave a Lewis basis, that is your electron donor, and that the presence of the lone pair on highly electronegative atom like nitrogen, oxygen, fluorine, and hydrides that result in the hydrogen bond formation between the molecule, and that leads to the associations of the molecule here. So we have group 15 to 17 we have, and where NH3, H2O, and HF. This has 1 lone pair, 2 lone pair, and 3 lone pair respectively. So now we go for the question that we have to talk about it, and then we will be continuing with the next coming class. So question is, would you expect the hydrides of NO and fluorine to have a lower boiling point than the hydrides of their subsequent groups members? So that what you have to answer it out here. So let's go for the question first. So the question we have, that is the second question. So would you expect the hydrides of nitrogen, oxygen, and fluorine to have lower boiling points than the hydrides of their subsequent group members? You have to give reason. So in the same way, so for here it will be on the basis of molecular masses of NH3, H2, and HF, and their boiling points are expected to be lower than those of the subsequent group members, hydrides, and however, due to the higher electronegativity of nitrogen, oxygen, and fluorine, the magnitude of hydrogen bonding in the hydrides will be quite appreciable, and hence the boiling point NH3, H2, and HF will be higher than the hydrides of their subsequent group members. So for that, on the basis of molecular masses of NH3, H2O, and HF, their boiling points are expected to be lower than those of the subsequent group member hydrides. However, due to the higher electronegativity of nitrogen, oxygen, and fluorine, the magnitude of hydrogen bonding in their hydrides will be quite appreciable. Hence the boiling point. So hence here that what will be going for it, that the boiling points in H3, H2O, and HF will be higher than the hydrides of their subsequent group members. So we'll discuss the rest of the question in the next coming class. That has been the another important is your 12th one. So here we're gonna end up with thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in a comment box. Please like, share, and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in a comment box. As before that, we had done many of the units here, and let's say we had dealing with the quantitative aptitude. Here we had done your that is your arithmetical ability. In that we had done your 17th topic, and in terms of it coming towards chemistry here. So in physics we had part 1 we had started with, where we had completed your unit 3 here. In terms of physics, chemistry part 1, which we had completed, that is some basic concepts of chemistry, structures of atom, classifications of elements, and periodicity of the properties. Then unit 4 is your chemical bonding and molecular structure. Unit 5 is your states of matter. Unit 6 is thermodynamic. Unit 7 is equilibrium, which we had completed. In the same way, we had completed your reasoning, which is your verbal reasoning and the non-verbal reasoning. And other than that, we had done many more. Coming towards chemistry part 2, which we are dealing, where we had completed your redox reaction, which is classical idea of redox reaction, oxidation and reduction reaction. Redox reaction in terms of element electron transfer reaction, oxidation number, redox reaction and electrode processes. Unit 9 is your hydrogen, which is positions of hydrogen in the periodic table. Dihydrogen, preparations of dihydrogen, properties of dihydrogen, hydrides, water, hydrogen peroxide, which is H2O2, heavy water, D2O, and dihydrogen as a fuel that we'll have to cover up here. After that, unit 10 is the S block element. Unit 11 is the P block element we have to cover up. Unit 12 is your organic chemistry, some basic principles and techniques. Unit 13 is hydrocarbons, and unit 14 is your environmental chemistry. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.